Alright folks, this will be part 2 of our F-Tafel series. I did the part 1 did the calculations using the F-Tafel for a 2-star fix with Alpharets and Altair, and I ended up with these two, excuse me, let me just get rid of that, these two pieces of information here. So our azimuth was south 73 east for Alpharets and 1.4 nautical miles away from the body, meaning that our observed altitude was lower than our computed altitude by this amount, 1.4. And then for Altair, southwest 20 at 1.8. Right, so now we need to get those on the map. We need to plot them. So what I do, and I use, just I'll preface this by saying I use this latitude longitude tool here, this grid tool. It is available on Subsim for download. I think it's called something like Map Cursor, but anyway, it shows up as a tool you can access over your E using the E key. It has its own little section here under maps. Okay, so I like it because of all the gradations on here. You can pretty exactly determine your coordinates just by at a glance. So my DR position as of the time I took the site, and this is the fix right here, but we're going to plot it. We'll hopefully arrive at these numbers. So my DR position as of this particular time was, as we noted the other day in our other video, was 55 degrees 58 minutes north. So you can see 55 degrees 55 6 7 8, so right there, and then 4 degrees 33 minutes east, so that's 4 degrees and then 33, you can see roughly there. Okay, right, so what I typically do is I plot from a separate area in the map, and I just basically do almost like I've got a piece of paper, and I just do my stuff off to the side here, and then I'll transfer the fix onto my actual position. Okay, so I know that my intercepts are pretty short, and so 1.8, 1.4. So what I'll do is I'll just zoom it in until I get, and I'll just use the units as they are. This is nautical miles, but all we're really concerned about is just using a unit of measurement, right? So what I'll do is I'll just get it down here to this 1800 meter scale, and then I'll use that, because so 1800 meters is going to correspond to 1.8 nautical miles, if that makes sense. So we're just going to we're going to use the units, not caring about use the numbers, not caring about really what the units are. All right, so the first thing I need to plot is south 73 east, 1.4 away. Well, when you see this minus, when it's minus, you need to flip these the signs, so it's going to be actually northwest 73, because we have to plot away. We're not going to be plotting down this way, it's away, and we have to plot up this way. Okay, so I know it's going to be north 73 west, because this is minus, the intercept is minus. So what I do is I do my protractor, my angle, whoops, get it straight, make it pretty long, because we'll need some kind of a vertical there later on, so make it pretty long. Okay, so 73, like so, and then I know it needs to be 1.4, so I'll make one that's 1.4 kilometers. I'll use that as our units. Okay, so there we go, and I put that here, and then I measure my intercept like so. Oops, there we go, and then I do my 90-degree line of position from there. Okay, so 90-degree line of position is going to be from there. We might actually have to go down this way. And instead. Okay, so 90. There we go. So really it's just a line that's running as a tangent to this circle, right? So, alright, so that's our first one. Our second line of position is going to be, we have to draw southwest 20, and we will keep it as southwest 20 because this is plus, the intercept is positive. So we will flip this around, go down, this, okay, and then we'll bring our angle down to 20, and then this needs to be 1.8, so we're going to make it 1800. There we go. Okay, now we draw our perpendicular from here like so. That is our fix right there. Okay. However, one thing we need to do is we need to do what Alfred's calls the spherical transfer, and we need to do that because we are plotting on a flat surface. The Earth in SH5 is also flat. However, when you're plotting the lines of position, you would typically plot these on like a plotting sheet that would have that has a sort of a makeshift Mercator projection, so that you've got actual converging lines of longitude, where we don't have that. And so the answer we get based on observing the celestial bodies is actually not correct by basically the secant of the angle of our latitude. So secant being the inverse of cosine, so 1 divided by the cosine of the, if you wanted to do it with a calculator, you could figure it out as this distance here laterally, right here, divided by the cosine of your nearest latitude degree. But you can also solve it graphically, which is what we will do. And we do that by extending your vertical here, and then we draw an angle from the fix that we think we're at toward our dr longitude here, and we make it the closest latitude, which is 56. Okay, and what we then do is we measure the distance of that hypotenuse. And remember, we're working in nautical miles, right? We're working in nautical miles. And so that 3 is 3. We just round it down to 3. We don't need to worry about decimals. So what we want to do, our dr position was, our dr position was 55, 58, 433. So our longitude is not, so this here is 433, but we just figured out that we are 3 nautical miles west of that. So our actual position is, in terms of longitude, is 4 degrees and 30 minutes, because I adjusted that over by 3. I didn't adjust it over by this distance, because that's not right. We need to do this transfer. So we draw the angle, and it's always in the direction of that the fix is to your, relative to your dr longitude. We measure this distance here, the hypotenuse, from the fix to our vertical. That distance is how much we are west, in this case, or east, in other cases, from our dr longitude. So 3. So, and then we take, what was our dr? We noted that already was 433. So we need to go west by 3 minutes. So that's our fix is 430. Okay, in terms of longitude. Now we just figure out what latitude is. So we know we had to plot from not our dr latitude of 55, 58. We actually plotted from our, we have to plot from our dr, from the nearest whole degree of latitude, which in our case is 56. So these angles here were drawn assuming 56. Okay, So I want to then measure how much further south than 56 we are. So I can just take this and then just measure down like this. So this is, we know this is at 56. This is where our fix is. Okay, 1, round it down to 1. So 1 nautical mile. So we said our we plotted from 56. So minus 1 is 55.59. 55.59. Okay, so that's how you figure out where you are, just using it off to the side like this. All right, so again, you plot both azimuths. One was up this way, the other one was down this way, and then you draw your perpendiculars to those. Those are the lines of position where those intersect would be your fix if we were plotting this on a projection chart, but we're not, so we have to do a transfer to figure out what our true longitude really is, and that's all we're doing there is just drawing an angle up to the vertical like this to your dr longitude, and then measuring that distance. That is the actual amount of longitude you're off by 3 minutes in our case, 3 minutes. Okay, so then we took our dr longitude, which I don't have listed here, but it was 4, in the last video we said it was 4 degrees 33 minutes east. Well, we need to go 3 minutes west, so that's 4 degrees 30 minutes. And then for longitude, or for latitude, excuse me, it's easy. We knew we plotted from the nearest degree. We used the nearest degree of latitude, which is 56 degrees, and it's just measuring down how far down we are, and we are 1. Forget that this meter even exists. All I'm doing is just using the units in thousands. Okay, I could zoom way in and use them in 12.5 or 1.2 or whatever, but you get the idea. It's the same regardless. Okay, so all we're trying to do is figure out what our new coordinates are. So we got those. Right, so then we come back up to the appropriate grid. We get our grid up here, and we align it, and we say, okay, we need to plot the actual fix that we figured out. And we figured out that was, it takes just a little finessing to get it close. That's close enough there. Okay, so then the trick here, and my friend Hunter had showed me this. This is good to know. You just keep your finger over the E key, and then to figure out your coordinates, we know it's 55.59 north. So we select our ruler tool, and we find 59, which is there. You can see 50, 55, 56, 57, 58, 59. Put it over there. Hit E, draw across like this, and now we do the same thing for our 430. So we do the same thing for, here's 30. Whoops, right there. Draw a vertical there. Yep, just like that. So this is where we actually are. Okay. This wasn't my DR position. This was a position that I had, a DR position. Excuse me, a DR, not at the time of the site. It was earlier. Okay, so we're a little south of our line. Okay, so then what I would do, since it's a fix, I would reset the DR line to that, like this, and then measure the new course I need to steer, which would be, now it's still about 298, so we're probably good there. And then just do some cleanup. And then what I also like to do is I like to put a circle around there, just indicating that it was a fix versus a DR, which is just the X. Okay, and then I can get rid of all of this work down here that I did. Okay, so that's how you would plot. That's how you plot the fix on the map, using the transfer, using the things that Alfred's has shown in his videos, and it's also in the instructions of the F-Tafel too, how to do all that. That's basically the same type of plotting that's done in the instructions in the document. But if you have any questions, let me know in the comments. But otherwise, that should be it. Thanks.